How's it going, everyone? Welcome, Eulier Gonzalez here. And today let's going to now explore about what a merge and rebase means at a low level in Git. Because most of the time, so far, with merge, we have a lot of conflict, especially when you have to now is take all of this commit or this state of your repo, state of your application, right? And then when you have to now is merge different state of your application that have different history, the question is that what is doing behind the scenes and how now that Git merge those state into one. And this is what we're gonna do in today's video. All right, now this is a course taught by the Prime Jim, a software engineer that is currently working at Netflix. And this is a brief course, that we have now the introduction, Git basic, branching, merging, and rebase, which is something that we're gonna focus our attention here in today's video. And then explore is the working with remote repository, conflict resolution, Git tools and techniques. So let's get into this. So Git is just this annoying tracking the annoying tracking file system that, unlike Linux Torvald, who create this, so we as programmers, mere mortals, can just be at his level, or at least small to that. Why is that? Because Linux can hold the entire core kernel on his head. And this is the role of a lot of tech leads. Now, the thing here is that this particular approach is something that we want to do, especially if you're going to build a particularly online business, right? You want to be the person that when a fix needs to be done or a new feature needs to be added, you're the person to go. So the introduction of this is that this Git is this distribute version control system, and it is an acyclic graph, which means that the relationship between this data is from child to parent, where now each one of those nodes is a commit that has information like the tree, the parent, the author, and the committer. And if you dive deep into the tree data, you can see now is the hash, which now store is a reference to a file location as well as a binary file, and that also contains a hash or a SHA, the secure hashing algorithm, which is a 40. It's a string of. It's an alphanumeric 40. It's a 40 string alphanumeric length. It's a 40 length. Is a Jesus. How do you say that? It's a 40. Is a 40 string. Yeah, it's a 40 string character length. It's a 40 character length. It's a string. Jesus. It's a string of 40 characters, or it's a string of 40 characters length, alphanumeric. Okay, so it's an alphanumeric 40 string. It's an alphanumeric 40 characters size that it generates based on data like the author, the content of the file, the time. So this idea, and also the message. So this hash or this SHA that contains now on the node, the commit is a reference to a file, and that file contains now a reference to the content. And the idea here is that we walk through what is Git is all about. All right. Now, Git is this data structure that, as I mentioned before, the powerful stuff of Git is that it allows us to contain the entire state of the applications. It's not storing diff and stuff or any stuff like that, which is something that I thought before this course. It's stored diff. No. It's storing the content, the entire file, the entire state of your application. Right? So we explored that about the basics of Git, which is what are the architecture of Git. So you have now the porcelain and the plumbing commands. So most of the time we're going to look at the porcelain command, the 14 most common commands, because now Git has over 140 commands, and this is something that, of course, it's going to apply the Pareto principle, right? So 20% of the effort to get 80% of the result, which is what we want to get, at least very dangerous in trying to solve any problem that can come up in our workflow. So this is Git. And this porcelain and plumbing commands is part of the architecture, as well as other concepts that are important to know, like the repo, which is the track project folder, the commit that contains the state of the applications in a SHA, all right, that has now all of these pointers to the file, and the pointer to the file, and the files have a pointer to the content of the file, and stuff like the working index. So for example, like this, key terms, like, and the index or an staging area, all right? Squash, when you can take several commits and make it one, okay? The work tree, the working tree, or the main working tree, this is your Git repo, stuff that Git will track in that folder. They call this working tree, okay? So you have the working tree, you have now the index, which is a staging area, and then you have now the track. So this is the place where you can put your folders in. This is the Git workflow here. So you have all of your track folders, which are on the working tree or main working tree, and then once you add those files to the stage area, when you do a git add commit, you add them to the stage area. You also make sure that you want to check that those files are what you want to add to, and then you go to the track, which is now telling Git, hey, I want you to generate a commit with this message, generate the SHA that will contain now a tree property inside of that node that will have is the folder structure, right? That property will have a pointer or a SHA that points to the file, and that file will have a pointer that points to the content of the file. So this is the idea behind the Git, right? And also, well, we can actually do that. So we started to create our own Git repo. So we initialize our Git repo. So we look at what is doing Git behind the scenes when create that. And also to get ourselves familiar with the folder structure of Git. Then do a simple Git commands, all right, like git add, git status, and git commit. See what's going on behind the scenes, what is Git is creating that, and then you move on to the other topic, which is how you can configure Git, right? How you can have access to the Git configuration. So Git here on the config, which is something that you barely touch, but it's important to know that you can add is data under the section as well as the key and the value, all right? and you can is define is some global configurations, such as the author of the author name, the author email. It's like, who is going to stamp this, bro? And also the additional data that you might want to have or add to, and also how you can set up your initial branch. All right. So with that, and also look that at the end of the day, git config is that git is access into a text file base. So git, in some sense, is stateless for the config file because it doesn't know what it is. And that to me was mind blowing, because git it needs to be checked, or they must have a folder in there to say, hey, I don't know where I am. So when you run git, it say, okay, let me look at the git folder and say, okay, I know where I am. That was quite revealing to me in the case of git. So then we look at how can we create these branches and what a branch means, which is just a commit from where you are currently. Is just a branch is just a reference or a 40 length character. A 40 length character, or a string of or a 40 length character string, alphanumeric, plus the name of the branch that is stored in a folder that points to the latest commit. That's the SHA that points to the latest commit at the time that you create that branch. So this is the reason why branches are virtually inexpensive, because it's just storing is a small amount of this information. And it's interesting because it's working a lot with pointers. So we look at what a branch is. Okay, so now we know what a branch is behind the scenes, and also where the branch are stored under the ref folder, right? So for example, here under the ref in heads and tags, all right? That was quite revealing from ourselves. And also how you can have access to the content of a SHA, right? A content of a commit. So this is branching, right? So far we created a branch. It was nothing that strange for us, but as you can see here, is creating now this particular branch, heads, foo, and trunks, all right? And this is because they are pointing to the same place. So now we create this particular branch, and we're going to now merge with this, okay? So this is what we're gonna do in today's video. Let's get into this.
This section, you should have this set up. Hopefully everyone has this set up. So now we're gonna need to do the exact same thing to trunk, except for we want to have D and E. This time, I do want you to edit the README file. So the README file will contain 2 or 3 changes now, A, D, and E. Then we'll have a second file called second.md that's only on foo. So to be able to make these changes, you first have to check out trunk. Now you need to make these changes one at a time onto trunk. So I'll use the identical process here. I'll do D, and this is gonna go to README. I will add it, I'll commit it with the message D. Very important to do that. I will now add the next commit, which is gonna be E. Add it to README, stage it, and then commit it with the same message. So now, if I were to do a git log, I'll do one line this time. You will see trunk points to E, which has D and A
this one.
in the past. I can actually use git, you know, you can use git log with the branch name. So I can do foo, and you'll see foo, CVA. Perfect. So we have these two set up. I can see
So what I want to do is to double check here this. But it's like an old instance of this. What about now? What about now? Yeah, there you got it. Okay, so get clear, git flow. So I want to know is the git log in one line. Okay. So this allows me to see is the previous change exactly. So remember the relationship is from child to parent. So you have now E, the change E, you have now the change of D and A, at least in this branch, right? Which is good. And if you switch or if you log from another branch, for example, like foo, one way to look at branch is using branch. Okay, you can see all of the branch. You have now trunk and foo. All right, you can also do something like this to look at all the branches, even remote branches. All right, foo and trunk. So we have these two branches to say, hey, git log one line of foo. All right, so foo, you have now A, B, and C, right? Or I prefer to say now from top to bottom, right? Remember the relationship here is in that order, from child to parent. So you have now C, then you have B, and then you have A, right? So we have now is a branch called trunk. Let me show you this. Okay. I think it is this one? So, okay. So we have right now is the branch foo with those changes. Okay, you say git log one line and say foo. All right, you have now C and B and A, which is great. And then we have another branch called trunk, which is now had is E, D, and A. All right. So far so good. So now we're going is to merge them.
Trunk is correct. I can see foo is correct, and I have this setup right here. So now it's time to merge these two together.
Okay.
There's actually two different ways you can do it. There's merge and there's rebase. We'll go over rebase at some point, but we're going to start first with merge. Now remember, a commit is just a set of changes in the entire code base at a specific point in time. And if you have work on one branch, and
so merge is an attempt to combine two histories together. And this is when the stuff is getting interesting, because I'm attempts to now combine is these two state of the applications to see if there is not any conflict there, right? And that's not easy. If you're trying to combine, for example, two different stuff, all right, you at least needs to see how they fit together.
you need to get it over to another branch. We're going to use merge. Now, the thing about merge that's a little bit confusing is that when you use merge, you can have kind of two different outcomes. You can have one that has a merge commit and one that doesn't have a merge commit. And you've probably experienced this where sometimes you merge and you have to input a message, and then sometimes you merge and you don't have to input a message. And there's a very specific reason why, because it depends on your history.
And this is when it comes, and this is it, bro. This is it. I think that I already take note of that. So now remember, is that a commit is a point in time with a specific state of the entire code base. So we have work done, but it's on another branch. We need to get it back into our main branch trunk, but how? So now remember that a commit is just a set of change to the entire repo at a specific point in time. Okay, and you might have two scenarios when you merge. You may experience an input message to put. Okay, you may experience put an input message or show or display an input message. So you may experience displaying an input message and an input message or not, and it depends on your history. So you may experience displaying input message or not, depend of your history. And this is quite revealing, bro. Absolutely, abso-freaking-lutely, bro. Abso-freaking-lutely, bro. Okay, here we go, fellas. All right. Okay. Cool. Cool. It's because they have two different states. It makes a lot of sense. It's like, exactly, so ask yourself, how do you merge two different history together, right? That they don't have any conflict. Okay.
We'll go over that in just a little bit. We'll create the two situations which exist. So what is a merge? A merge is just attempting to combine two histories that may or may not have diverged.
Okay, so according to you, okay, so according to you, a merge is an attempt to combine two different, but only two, right, or more? Exactly, two histories together that have diverged at some point in the past. So a merge is an attempt to combine two different history together that have diverged at some point in the past. Okay, two different histories that have diverged at some point in the past. So you have one history, and then suddenly someone needs to have this commit, so it create a branch, and by a branch it's just a reference to that SHA. Then it's going to create now new commit on top of this, right? So when it create this new commit on top of this, so you have now two different histories here. So two different state of your applications. And then at some point you need to, or you might want to merge that, to rebase, merge that, right? It makes a lot of sense. Okay.
Diverging means like how we set it up. A is in the past and we both share A, but there could be 0 or more commits in both branches.
There is a common commit point between the two. This is referred as the best common ancestor. This is a common point. Okay, this is a common commit point between the two. So there is a common common commit point. There is a common commit point that is between the two. Okay, this is referred to as the best common ancestor. This is referred as the common ancestor. Exactly. This is referred to as the best common ancestor. Why best? This is referred as the best common ancestor. Merge base is often the term used in the doc. Technically speaking, it's merge base. Merge base is the term used in the docs. Okay, okay.
That cause us to diverge. Now, whenever you are merging, get used to something called the best common ancestor, which is going to be the first in common commit. So for us, we have
It'll be the first incoming commit. So this merge base is now the known common or is the best common ancestor, where now it's the best common ancestor from these two branches, or from these two different histories.
ABC and we have ADE. A is the best common ancestor. Something called the best common ancestor, which is going to be the first in common commit.
Which is going to be the first in common, which is going to be the first in common commit.
So for us, we have ABC and we have.
So we have ABC, if you remember a little bit that. So we have now ABC in this order. So we have now ABC, and then we have ADC, okay? So A is the best common ancestor.
Have ADE. A is the best common ancestor. In the
A is the base common ancestor.
docs, you'll often see it's called a merge base. And so really it's just the first thing that's in common. So if you were to walk.
So it's the first that is in common too, exactly. So is the first commit, is the first common commit. So it's the first common commit between histories. Okay. So if you walk through this, because if you walk through each history, you will find is the common ancestor or merge base. Okay, it makes a lot of sense.
Up the tree. Like if you were to think about you having to write this algorithm, you literally start at.
Exactly. So imagine that. So imagine that you have to write this algorithm. So you'll have to look at this relationship from child to parent. So you will have to look up backwards. Okay, so you will have to look at backward from child to parent until you find. Okay, so you will have to look at backward from child to parent until you find that common commit.
Each commit, and you just keep on walking the parents with the hash map, by the way. You'd want to use.
So with a hash map, because you want to keep track of this.
Use a hash map here, unironically. You'd use a hash map to contain, or really a set, to contain.
Exactly. You use a hash map or a set to contain all the commits.
All the things you've seen up to this point, all the commits.
So with a hash map or a set, that you contain all the nodes or commits you have seen. Makes sense. All the nodes and commits that you have seen until you find the equal, until you find the first that is equal.
Commits you've seen up to this point, and the first time you have something that is in common.
Exactly. You see until the first commit until and you have seen exactly. So you find that common commit with a hash map or a set that you contain all the nodes that you have seen until you find the first common commit, right?
You know you've just found the best common.
Exactly. So you know that you find the best common ancestor. So now this particular process or mechanism where it allows us to describe what's happened behind the scenes, we can now understand or at least have a sense of what Git is doing when it merging stuff. It's like walking through both of this. It's like walking through both of this stories. Yeah, walking through all of this history until it find a common ancestor known as the merge base. And then what's going on is that it needs to merge the top of the commit and see if there any change for that.
Ancestor. Funny enough, it's always a hash map. I don't know why, but it just always is. Anyways, Git then takes these two commits that you have.
Yeah, it is funny. It's like it's always a hash map, bro. It's always a hash map, bro. A hash map has sets that allow you to keep track of all of the different nodes that you have seen and all that kind of stuff. It's a record. You gotta keep tracking that.
Checks out the merge base or the ancestor. Funny enough, it's always a hash map. I don't know why, but it just always is. Anyways, Git then takes these two commits that you have, checks out the merge base or the best common ancestor, then plays those commits on top of it, creates.
Exactly. So it checks now so Git now checks the merge base of these two history, and then going to now add all of these different commits. Because that's
Git then
it,
takes
yeah.
these two commits that you have, checks out the merge base or the best common ancestor, then plays those commits on top of it.
Then plays those commits on top of
Creates
this.
a new commit called a merge commit, and that will actually have two parents. It'll have one parent from one branch and one parent from another branch. And then
Exactly. And it's gonna, okay, this is on the merge creation. It's gonna get the merge creation. So now it had created a new commit with two branches here.
that is a merge commit. And so this happens, that's what you'll get a message because you have two different diverging branches. So we'll go over that. Here we go. All right, so how to merge another branch. Creates Git then takes these two commits that you have, checks out the merge base or the best.
Exactly. Git takes all of this merge.
Funny enough, it's always a hash map. I don't know why, but it just always is. Anyways, Git then takes these two commits that you have,
Okay.
checks out the merge base or the.
Okay. So the process here is that Git check out this two commits that you have. Okay.
Best. Funny enough, it's always a hash map. I don't know why, but it just always is. Anyways, Git then takes these two commits that you have.
Git takes this two commit that you have, aka the branches. Okay. Okay.
Checks out the merge base.
page. Exactly. Check out the merge base of the common ancestor, the best common ancestor, okay, and then place those commit on top of it, okay, play those commit on top of it, creating a new commit
or the best common ancestor, then plays those commits on top of it.
Exactly.
Creates a new commit called a merge commit, and that will actually have two parents. you'll have one parent from one branch and one parent from another branch, and that is a merge commit. So this happens, and that's what you'll get a message because you have two different diverging branches. So we'll go. Here we go. All right, so how to merge? Very, very easy. You have a target branch, which is the branch, and that is a merge commit. And so this happens, you'll have one parent from one branch and one parent from another branch, and creates a new commit called a merge commit, and that will actually have checks out the merge base or the best common ancestor, then plays those commits on top of it.
Then plays. ¿Por qué? ¿Por qué? ¿Por qué? ¿Por qué? Jesus. Enough.
Git then takes these two commits that you have, checks out the merge base or the best common ancestor, then plays those commits on top of it.
Then plays those commits on top of it. Then plays. Exactly. Exactly. Place those commits on top of it. Okay. Exactly. That makes a lot of sense. It's like it takes these two commits you have, it checks out the merge base or the best common ancestor, and then place those commits on top of it. And they place those commits on top of it and creates a new
commit called a merge commit.
Called merge commit. Create a new commit called merge commit. That will actually
have
two parents.
You'll have one parent from one
that have two parents.
One branch and one parent from another branch, and that is a merge commit.
Creates a new commit called merge commit that have two parents from
commit, and that will actually have two parents. You'll have one parent from one branch and one parent from another branch.
Exactly. But this is the process. So anytime that you do a git merge, all right, the process is that Git will take this two branches, okay, it will take these two commits you have, it's gonna check out the merge base, okay, and then place those commits on top of this and create now a new commit called the merge commit that have two parents.
And that is a merge commit. And so this happens, that's what you'll get a message because you have two different diverging branches. So we'll go over it. Here we go. All right, so how to merge,
So this is a very dangerous place to do, because especially if you are going to have your own private repo. So for private branches, it is preferred to use now Git rebase. But for common branches or for public, you need to do a merge for that.
Very, very easy. You have a target branch, which is the branch you are on, and
So git merge is that, and that's my confusion. That was my confusion here. That was my confusion here. So git merge is gonna merge the local branch or the branch that you're curling at, the target branch, with the source branch. The branch you are is a target branch, and the branch you are in the branch you name is the source branch.
You have a source branch, the one you wish to merge with, and the source branch is going to be the one that you provide the name. This is how I think about it, at least. I think this is probably the easiest way to think of it. And so you'll do git merge the branch you wish to bring onto the one you're currently on. So let's do it now. Let's merge foo onto trunk. But remember, we don't want to ruin our current trunk state, so I want you to check out a branch called trunk merge foo.
Okay, so let's get into this. Screenshot. Okay, problem. makes a lot of sense. Okay. So I know what the process of this merge is. So you have to be careful about that. You have to be careful about which merge you want to do, you're gonna insert. So this requires you to be a tech lead, bro. This requires you to know the entire code base and that anytime that you do a merge, it doesn't crash.
Merge foo onto trunk. But remember, we don't want to ruin our current trunk state, so I want you to check out a branch called trunk merge foo.
Okay, so I want to check out this, which means that it's going to create now a branch from where? From please start your branching off. Okay, please start by branching off of trunk. I name my trunk merge foo. Let's get into this. Let's definitely get into this. All right. So here we are, which is warp. La 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 la. All right. Warp functional IGS warp. Here we are. Okay. So we're gonna create now we're gonna branching off of trunk, which is this, and to do this, we're gonna create is a branch, which is just a commit. Is a reference to the commit that you're currently at. You know, that's one of the reasons why I'm doing all of this, is because it is important to be able to describe what's going on here for yourself, because you have much more clarity. And the role of a senior developer is that not only that somebody that can solve something, even though he hasn't solved that before, okay, and then can now jump out of that successfully, so jump out of that block successfully, but also is someone that can provide meaning to others. So, oh my God, here we are. We're gonna create now a branch, which to me, this is one of the things that I don't like about branch, is that you create a branch, but it doesn't switch you off, okay? That unlike switch, it say, hey, create the branch and then switch it, okay? And then switch. So the C here stands for create, so create the branch and switch. That's what I prefer, use switch instead of branch. But in any case, so yeah, this is this new branch that we're gonna create here. Makes a lot of sense. Makes a lot of sense. From trunk, I named trunk merge foo. Okay. So let's get this. So trunk merge foo. So trunk merge foo. Okay. Damn, we did it. What we just did is, if we take a look at find the git, we have now is all of this. So you see, trunk merge foo, and trunk. This is a reference here. Again, if you're gonna get, you're gonna concatenate and print that out. Concatenate the output and print that out is the git ref trunk merge foo. What will be the expected output? Well, is this string, this SHA reference followed by the name. You know, is the SHA, which is the commit. You know, so it's the commit followed by the name of the file. So if you want to have access to this commit, for example, say git cat file -b. Okay, the first 7 characters are relevant here, and then you can see now is the structure of Git, this acyclic graph, or at least this particular node, right? Which is, hey, you have another tree that points is to this folder structure, the parent, okay, and this children to parent relationship as well as the author or the committer. So if we go down to this, or if we walk through this, hey Git, I want to show me is the content of this SHA 365, right? It say, hey, I have now a file. Blob is a binary large object. I have this file that contains now the SHA. This is a reference, and the folder name. Okay, so if you want to know the content of this file, so we can is just copy this, right? And you can see what you have in there, right? So the readme have is A, D, and A. This is the content of this file. Okay, so again, now that we create this branch here, which is now I know what technically is happening here. It's not a branch, it's just a fancy way to say what's going on, but this is just a commit. It's a reference to the latest commit at that moment that you create that branch, that you run that command.
So I'm gonna go git check out trunk merge foo.
This is another way of how you can do that, right? You either use git switch, or you either use git checkout b trunk merge foo. Okay. So hey, I want you to check out and then create the branch.
Have my new branch, remember.
Which is interesting, which is what happened here. See, switches to a new branch, trunk merge foo. Switches to a new branch, trunk merge foo.
Dash B just creates a new branch if it doesn't exist. Awesome. So now I'm gonna go git merge foo. There we go.
So if I say now git merge foo, remember that what it's doing here, okay, is that we are now merging is the current branch that we're at with this branch. Okay, so because now trunk merge foo is now has a reference on the trunk. Okay, and trunk, if you remember, trunk, the structure of trunk is now has a diverged history command. Okay, so in other words, it has two different history. So here we're gonna see is now is the input command like this. It says like, hey, what happened here is that you have now two different history here, and I want you to Git. What it's doing is check all of the. So Git is checking is these two branch. All right. Walk through the best common ancestor or the merge base, and then place on top of that all of this commit to put and creates a new commit on top of that, which is the merge commit. And this is what a merge commit that has is these two parents, the parent from one branch and the parent from another one, right? And this is what a merge commit is. So anytime that you see this, is that, oh my God, we have now two different history here. And here we are going to create this commit.
Yeah, we're presented this menu saying, hey, we need you to merge this together. We want you to add a commit message. It's been auto-merged for you, but we still need a commit message.
So git checkout -b with the trunk merge foo. Okay. Git your commit, and then you say is git merge the current branch that you are, which is trunk, and foo, right? So you can see we are looking at this. We are looking at this one, right? We are looking is at this one. Merge branch foo into trunk merge foo. Okay. So what we are seeing, okay, so what we are seeing is that git auto resolve our auto resolve this because
together. We want you to add a commit message. It's been auto merged for you.
exactly. What we're seeing is that git auto merge this for us, but we need to add a message to this.
But we still need a commit message. Because remember, a commit is a series of changes that represent.
But we need to add a message to this commit. And remember, a commit is a series of changes that you made. So a commit is a series of or is a set of change. It's a series of changes that to your entire base, exactly, that you do to your entire that you do exactly that you do. So remember, a commit is a serious thing that you do to your project that holds the entire code that holds the entire code base at that moment.
Represents the entire state of the repo plus an author plus a message.
It represents the entire state of the repo, exactly. That contains the entire state of your repo plus a message plus the message plus the author and the time.
And time as well. You probably see something like this, merge made by ORT strategy. That's
so if we run this, okay, we say, hey, good. How the fuck do I get out of here?
relatively new plus an author plus a message.
WQ, okay, so WQ
But we still need a commit message.
Holy shit, how do I get out of here?
Because remember, a commit needs you to merge this together. We want you to add a commit message. It's been auto merged for you, but we still need a commit message.
Okay. It was the problem with the editor V. Not committed. Not committing merge. Use git commit to complete the merge. Git merge foo. All conflicts fixed, but you're still merging. Use git commit to conclude merge. No, I don't want to. Git switch. Git switch to trunk. Okay. While merging, git merge quit. Okay, git merge quit. All right. So I want to git merge again with foo. And you say your local changes of the following file will be overridden by merge second. Merge with strategy or fail. So if I say git merge quit, git status, all right. You say git, well, let me git switch to back to trunk. Okay, git branch delete this branch. The trunk. Trunk merge foo. Okay, and then I want to create now a new one here. So git status. I didn't add that. Git diff. Exactly that. Git diff. Git log. One line. Decorate. Graph. That's right. EDA. You say git log. You git cat file to this. All right. Git cat file. Git cat. Why not? But in this case is with this. All right. And then I have this change ADNA. Yeah, well, git restore. I want to know the cat file here of the second. And it contains B and C, and say, well, git stash. That's right. So git stash now create is an index for on that. Okay. Okay. Git status. Exactly. So git status is this. So there is nothing in this branch. Okay. Good. So what I want to do is git branch all. I have only foo and trunk. I want to create from this commit is the branch to say, hey, check out, and then create a branch. Call is trunk merge foo. Okay. Trunk merge foo. Good. We create that, and then we say git merge the foo branch. Okay. So matches appear, which means that we have now the different histories here, because what it does is it check out the known common ancestor or the best common ancestor known as the merge base, and then it plays on top of all of those commits and create now a new commit that has now two parents. So my question is that how in the F do I get out of here? And there you get it. All right, so now it creates this merge from us, right? It creates this merge from us. Okay. But it's because we are now playing with Vim here. It's because it's playing with Vim here. Git merge foo. Merge made by ORT strategy, second.md to one file changes to insertion. So it's using now the ORT strategy.
Because remember, a commit is a series of changes that represents the entire state of the repo, plus an author, plus a message. And time as well. You probably see something like this, merge made by ORT strategy. That's relatively new. I think at one point it used to say like a three-way commit strategy, and now it's changed into the ORT strategy. All right, so when we're done, I want you to use git.log. So everyone that has just merged, use git.log and see what happens. And I also want you to use the term parents when you do git.log or git.log. When you do git log, I want you to add -- parents. So show the parent commits along with everything.
So let's get into this. So git log the parent commit. I think it's parent. Show me this in a graph. Decorate. What? Oh, because it's double here. So as you can see now, this is a very powerful tool, bro. Oh my God, this is a very Jesus. This is a very underrated tool, bro. Jesus, git log. Holy moly. So you can see is this the common ancestor that now from this we create is a branch, or we create is a new commit, a state of the repo with this set of change plus the author plus the time. Okay. that, as you can see here now, it has these two commits, right? It has these two commits. This is from the trunk, all right? And this is from the foo. Okay. This is from the current base that I merged, and then this is from the branch that I want to merge with. And it's this one. So you can see how this commit here, now Git behind the scenes create is a merge commit message. Or it now create is a commit, which is a series of states in a repo plus the author plus the name and the parent commits from one parent branch and the another parent branch plus the time. So these two, right? So this represent is the new commit created. But this, as you can see, this represent is the latest commit from the branch, which means that it represents the latest state of that. It represents the latest state of the repo at that time, okay? As well as that, it represents the latest state of that another repo at that time. And then it's now creating a new merge from that. This is interesting because what it's doing is to take these different representations of the state of the repo and then try to merge that. Holy moly, this is a very underrated.
So I'm gonna go git log, one line, graph, parents.
No, but I prefer to go with this. You can say git log, parents, graph, one line. And as you can see here is this one. You can say decorate without the one line. You know.
So you can see right here, the merge commit has two parents. If you look at this ID, this SHA, you'll realize this is trunk, where trunk is currently pointing to. When you look at this one, this is where foo is currently pointing to. This is C. This is E. And then now.
So in our case, if you take a look now, this in a more friendly way, patterns, or in other words, in a more short way, one line. So you can see that this commit is E here, and this commit is C, and this is the newly created commit. So on the first line, the first string is the commit, is the merge commit. The second is the branch that you want to merge. The target branch is the target branch. Okay. And the third is the base. Yeah, and the third is the blah, 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 blah. The second branch is the target branch, and the third is the source branch. The branch you wanna merge with.
Now with the graph, it's able to draw this nice graph because it has all that information. It's able to walk back the graph and be able to display for you so you can actually see in line what is happening. So there you go. That's pretty neat, right? By the way, log, totally underrated. Super cool utility to kind of know some of the things to use. All right, so now I want you to create the following Git setup. I want you to check out trunk, then I want you to check out a new branch called bar, and I want you to add 2 commits, X and Y. And X and Y, please put the changes into a bar.md file, or just some other file that's not readme. I use bar.md. I want you to check out trunk, then I want you to check out a new branch called bar, and I want you to add 2 commits, X and Y. And X create the following. That's pretty neat, right? By the way, log, totally underrated. Super cool utility to kind of know some of the things to use. All right, so now I want you to create the following Git setup. I want you to check out trunk, then I want you to check out a new branch called bar, and I want you to add 2 commits, X and Y. And X and Y, please put the changes into a bar.md file, or just some other file that's not readme. I used bar.md. So I'll do it with you. Git check out trunk, git check out dash b bar. I'm going to echo in
because
X
you're going to merge these two
bar.md.
with different histories.
I'm going to commit it.
You have this.
I'm going to do it again with Y. All right, anyway, so we've now created this right here. It's pretty straightforward. All you have to do is just check out bar, add the 2 commits. This is almost identical to what I just got done doing on the screen. Pretty easy. So we should now have the exact same thing. We should be able to use git log to see that we've done this correctly. So I'll do it right now, and we'll use the exact same git log that we're always using with one line, and we can erase parents. You don't really need to know parents. But you can see here, bar is at Y, trunk is at E. Can you say anything that's unique about this situation that wasn't unique in foo, or that was different in foo, shall I say? What's different between this setup versus what was done with foo and trunk? Foo and trunk.
That both diverge.
Both diverged. In this situation, bar is the only one that has diverged. Its best common ancestor is the tip of trunk. It's a very important thing to remember, or to observe, shall we say. So now let's merge bar onto trunk. So do the exact same thing, and this time we do not create a separate branch, just check out trunk and merge bar onto it. So I'm gonna go git check
so if
out
we
trunk,
check out trunk,
git merge bar.
they won't tell you now because they haven't diverged from that.
And you'll notice this time, there's no commit message. Why is there no commit message? Again, the best common ancestor was the tip of the branch you were merging onto, which means that it can just take the commits and just update the pointer. That's all it does. It doesn't have to do any sort of merging. It already works. You've already resolved any conflict. It can just simply fast forward the merge. So you'll often see in the documentation where it says ff-merge. It literally means you have a linear history with no divergence, and you can just simply take the commits and update the pointer.
But this another
About the
case.
situation that was identical to what I just got
This
done.
another case.
Be
This
bar,
another case is when
or
you
just some
have now. Okay, but this another case when you have now this is this. Problem and solution. Problem and solution. create the following git setup here. So let's going to create this following git setup here, and that is go to trunk. You say git now switch to trunk. Okay. And here let's going to create now this new branch called bar git checkout. You say git checkout minus b branch. Okay. Git checkout minus b is trunk bar bin bar. We create bar and we check out to that. Okay. So if you take a look at the git log, it actually have now from trunk, and we want to add some changes here to this branch, right? And that is branch bar of trunk add to commit with message x and a g and create your chains x and g in bar md.
Other file out dash b. I'm gonna do it again.
Okay, so let's go to create now echo here of g x x, and then now that output concatenate with within a file called bar md. Okay, git add those change, git status, that's right, and then git commit with a message that will be is now called x, just like that, right? So we create effectively now this commit, this state of the repo that contain is now this that contains a set of state change, this that contain a set of change in a repo plus the author plus the name and the time, right? So we're gonna do the same now for this. Say echo. This is how you can print that. Echo now ye, and then using the bash operator to say, hey, concatenate this output on to append this content onto this file. All right, and then you say, hey,
Again with y.
say git add.
All right, anyway, so we've now created this right here. It's pretty straightforward. All you have to do is just check out bar, add the two commits. This is almost identical to what I just got done doing on the screen. Pretty easy. So we should now have the exact same thing. We should be able to use git log to see that we've done this correctly. So
that's right. So let's get into this. Screen share. We create this. Okay, we successfully create that. So we successfully create that, right? And the other one as well, which is this one. All right, cool. It's this one, we create with X, and then we create with G. No, there is no need for this because it's here. That's right, and there you got it. All right. So now let's go to see if we have done that as expected, right? If you see git log with patterns and graph, and show me this with one line. All right, as you can see, we create now is a bar like this. So with G and then X from the commit of E, okay, from the commit of E, and then D and then A. Okay? So far so good. Now, because when we run git log git log graph parent one line, okay, we got this. We got this. All right. So when we merge bar with trunk, okay, because trunk doesn't have any, and this is important because trunk doesn't have any commits on top of that, or aka aka the history is the same, or because Tron doesn't have any commit on top of that, okay. When we run the commit, when we run the merge, it will auto merge that for us, okay, without creating a new commit, which is what it does here.
Between this bar is the only, or to a merge bar onto it. Why is there no commit message?
Without creating a new commit message. Why? Because bar is the tip of the trunk, because bar changes, or bar branch is the tip of the trunk. Because bar branch is the tip of the trunk branch, they have the same history, okay. So they are not, so the, in other words, the best common ancestor, okay, is exact, because the best common ancestor, okay, yeah, because the bar branch is the tip of the trunk branch, the best common ancestor is trunk latest commit.
Again, the best common ancestor was the tip of the branch you were merging onto, which means that it can just take the commits and just update the pointer.
Is a trunk latest commit. So it just take all of the commits and update the pointer.
That's all it does. It doesn't have to do any sort of merging. It already works. You've already resolved any conflict. It can just simply fast forward the merge. So you'll often see in the documentation where
it just simply fast forward the merge.
it says ff-merge. It literally means you have a linear history with no divergence, and you can just simply take the commits and update the pointer. All right, so now we're gonna go from merge to rebase. I know everyone's excited about rebase. The thing about rebase is I am completely convinced people don't like rebase because A, they heard on Twitter that it's bad. B, they used rebase that one time, screwed it all up, and now they hate it and it's ruined their life. Therefore, rebase bad. It's not bad. It's actually fantastic. Rebase is just yet another tool in your get bad belt to be able to manipulate and use your repo effectively. And there's actually a really good reason why you should use rebase. We'll kind of get into it a little bit more. So this is our current setup right now. We have foo, which is BC, and we have trunk, which is all the way up to Y at this point because we have merged on bar. So this should be your setup right now. Now we can demonstrate the power of rebase by updating where foo points to. We're going to create this graph by using rebase.
Where
this is
foo
what
is pointed.
rebase does, is it allows you to update underneath your set of changes. And this is very important because it is rewriting history in some sense, but it's allowing you to have what is currently the reality, then your changes. As opposed to your changes that are tested against some previous reality that's no longer true, you can now have it properly in line and then to be able to find out, did you actually write something that's good or does it suck? All right, so, and this also means when we decide to merge foo onto trunk, we can do a fast forward merge.
So what you can do
again,
is that
our best common ancestor, our merge base, is
move
the tip of
your
trunk
change
now that we
to the
rebased.
latest version.
And this is typically why people really like rebase, is that it allows no merge commits. And there's a good reason why you don't want merge commits, and we'll cover a little bit later. All right, so basic steps of what rebase does. First thing rebase does is that you will first go get.
So hey, my local change, I want you to now move the pointer to the latest commit at that repo and then apply my own changes, right? And then figuring out how those changes actually fit together. Oh, crap. So in other words, the best thing that you can do is to commit often. Is to commit often. So, okay. Okay, so that'll be all for this video. Take care. Bye-bye.